I'm about to go over RIP1 and the problems that we tended to have, the general issues that we had. The domain and range of this function. So this is asking about this particular function over here, the one that is given. The domain is all of the values that if I have some sort of vertical line, all the values that get hit, all of the x values. So notice -1 all the way through 2, but then 2 doesn't get hit, and then from 2 to 5. So -1 to 2 and 2 to 5. Notice that 2 has a parentheses because it does not get, it's not in the domain, it's not getting hit by this line. -1 and 5 are in the parentheses, or in brackets, sorry. For the range, it works going this way. So -2 gets hit, everything's getting hit, everything's getting hit. 1 still gets hit, even though this is not a value. There is a y=1 value over here, so it continues to get hit all the way up until 4, which doesn't get hit. So -2 is a bracket, 4 is a parentheses. A lot of the issues that we had, a lot of us just had bracketing wrong, so this would be a parentheses. A lot of us did not take into account the issue at 2 where it's not part of the domain. A lot of us wrote the numbers backwards. We always go from left to right and from bottom to top. So for the range, it would be -2 to 4. A lot of us were using notation that we're not using in this class. So like these curly brackets. Again, we have this issue where things are not in the correct order. But this is something that we saw a lot, and I took a bunch of examples of it. A lot of people were treating this like it was 2 separate functions, where we have, like, we put the union in there, but we're treating it like this is the first line and then this is the second curve or whatever, where this is one function. So when it's asking what is the domain and range, it's this is referring to one function. So that means that we should not have multiple, and even if you have multiple parts, it's not like the parts are for separate things. If we were asking for the domain and range of separate functions, we would have actually specified that we wanted separate functions. So a lot of us are treating it like this is the domain of the first line and this is the range of the first line, when really this is one entire function. Problem 2. This one was hard. I had only a few students get full credit for it. This one is a student example of someone who got it totally right. But there are a lot of options. Basically, what has to happen is you have to hit every single value and this one actually doesn't work. You have to hit every single value in -2 to 7, and that's why this one doesn't work, because x=2 doesn't get hit. But you have to hit every single x value in -2 to 7, and the y values you have to hit -3, and then everything all the way up to 4, but not hit 4. And so that's why all of these work. Notice if I did a line and I scanned it, let's go for the green graph. Yes, yes, all the way. The red graph, yes, there is a point that works, and then all the way. Blue graph, this works, and then even here, this works. All of these graphs have that situation work, even the black graph, because notice there's a point right here. But all of these things work all the way up in the range, and then none of them hit 4. And then this one down here also doesn't work, because we have this situation here where the X value does need to hit, but we can't have Y work. So this one doesn't work either. And then lots of examples here, like can't do this. This is somebody who's thinking that you can get all the way up to 4, but not quite. The density of the real numbers indicates that you can't do something like that. You have to actually have it go all the way up and have an open circle. This thing is good for the Y, but notice that we have an X value that's missing. This one, there's an X value that's missing at 7. This one, no X equals 7, no X equals -2. This one is not a function because the yellow or the orange one, or yellow, orange, whatever it is, it's not a function because there are 2 values at the exact same X value, so it doesn't pass the vertical line test. And then we had a lot of people thinking things like this, where we can just draw 3 lines and think that it all combines to be 1. Well, when it asks for 3 functions, 3 different functions, if you draw 3 things and they combine to be 1 thing, that's actually 1 function. So this wouldn't even be a function if we were treating it like there were 3 of them, because it doesn't, or if it was 1 function, because it doesn't pass the vertical line test. But then if we treat it like it's 3 functions, none of them actually meets all of the criteria. See, for example, this one, none of these 3 things meets all of the criteria. Some of them start at X equals -2, but it doesn't go all the way to 7. We have a couple like this one. This person is treating it like all of these things combined add up to 1 function. And if that were the case, then that would work. But we need more than 1 function because the problem asks us for 3 things. This one is kind of similar, except this person's combined thing wouldn't pass the vertical line test. And this one is like missing, there are gaps here. So this has a whole gap between 0 and 1. This one, a lot of people were drawing it like it was a bucket, where it's like, I know I have to hit this, I know I have to hit this, I know I have to hit this, but I don't hit this. Well, a lot of people that were doing this had gaps between, like, this doesn't actually go all the way there. And then we didn't meet what we actually said we needed. So like this line means I need the hole filled. Well, the red one doesn't have the hole filled. Same thing over here. The blue one doesn't have this hole filled, and so on. Problem 3. Use the point that is given. The point -5, 2 is given, so you don't need to do any work to graph it. All you have to do is put -5, 2 on the graph and use the slope down 2/3, and then you're done. Part B, that's where you have to do something else, and it's actually pretty easy. You can use point slope form with this point, or even someone used y minus 4 equals -2/3 x plus 8. That's acceptable too. You can solve it for slope intercept or whatever. But a lot of people were using this as the only way that they know how to graph it. You do not have to go all the way to slope intercept in order to graph the function. Use the point and the slope that are given. See, we had some people that were graphing things that didn't even go and include the point -5, 2. Like that has to be on the line. Tons of people were having no work. And if you have no work, I don't know how you got this, because that's like a multiple step process to get to there. We also had a lot of people rounding decimals, which that's not the exact same thing as what it originally was. And a lot of people are using mixed numbers, and we don't want to use mixed numbers here because mixed numbers can kind of get confused with 1 times 1/3. So we often don't really use mixed numbers as we get into higher level math, unless we really need it, or there's a specific purpose for it. And graphing lines, we don't really do that. Again, just use the point -5, 2. We don't need to do all this work in order to graph this line. And then finally, a lot of people weren't actually saying that the line continues. A lot of people were just kind of stopping it. Problem 4, you have to multiply everything by n, distribute. A lot of people forgot the distributing. And then we need to get something that looks like ax plus by equals c. That's what standard form means. A lot of people were not doing standard form. Standard form, A, B, and C all have to be integers. So we didn't have integers here. And we didn't have, there were many that didn't have integers. A lot of people were deciding to just make n equal to something. This person made n equal to 5. This person, the n disappeared. I assume they made n equal to 1, but they didn't say anything. This person had n equals 1. They just made a decision. You can't do that. And a lot of people didn't do work, and a lot of people didn't put things in standard form. Problem 5, get a perpendicular slope. So perpendicular slope is opposite reciprocal. And then just write it in point slope form. Be done. Like, you can continue here, but a lot of people continued and then made mistakes. If it tells you it has to be in a certain form, then you have to do that. But otherwise, just leave it in the form that it was. Again, lots of people not showing work. A lot of people continuing after getting the right answer. This person got it right, but a lot of people continued and got it wrong. And then a lot of people did things like this, where they didn't use point slope, even though we were given a point and we found a slope very easily. And then we had to do a lot of this work in order to solve for B. And a lot of people made mistakes when they were doing this work. Just use point slope. It is literally one step. Problem 6, we have to use the slope formula. So you could go -2 minus 7 over -5 minus 4 also, and get -9 over 9, -9 over -9, which ends up being +1 also. And then I would use point slope form and then solve. The biggest issues, I didn't put a whole lot of work here. The biggest issues were people not using the slope formula correctly. A lot of people had x's and y's all mixed up. People putting things into point slope form incorrectly. And then not solving for standard form. That was a big issue. A lot of people left it as something like y equals x plus 3, which is not standard form. And a lot of people just randomly putting things that don't have work. Finally, a lot of people left it in these formats. And typically when we have standard form, we want it to look like ax plus by equals c. A lot of teachers make a have to be positive, but notice that a lot of people were leaving the y in front. In standard form, technical standard form, the x has to be in front. And that's RIP 1.